Alright, another draft science video presentation. Probably talk about gravity because I'll play a video about it and other subjects, no doubt. So, first off, Google is evil. Obviously, you shouldn't have corporations in charge, blah blah blah. But just even analyzing how they approach the idea of search and this whole first, it's not the default isn't search is just search. Everybody gets the same search. The default is they profile you, see your habits, and conform the search results to your preferences in terms of what they have established them to be, how they profiled you, what they profiled you into. So they give you different results than they give your neighbor, which seems like a really bad idea. I mean, to some extent, obviously there's times when, yes, they'll save me some trouble if you profile me correctly, as I don't want garbage websites or ad websites or spam websites. If they profiled me to be anti shit and trivial, then that might be interesting. But that's not what they profile. They profile what ads you click, what you buy, that kind of crap. And the whole idea of relevance, they've decided they know what relevance is. So you put a quote in text, they'll find one page that has the actual quote in it, and then they'll start just throwing in a bunch of results that other people thought were relevant to that quote. It's just noise. You want the exact quote. You don't want what other people think is relevant and all that crap. So, anyway, just evil. Corporate internet. It's a bad idea, but whatever. Talking to the wind. Because humans can't figure it out. So, anyway. Baldy Catz. Yeah, just, what despicable little character. Disgusting that he was actually a school teacher, because he has no character, no integrity. Just probably talks shit to the little morons. Probably was an arrogant douche, no better than some nun, whipping the kid over the head because he doesn't say God correctly. Just an asshole. He's demonstrated it. Hangs out with a bunch of fucking, and you say fucking because they're just such low-grade humans. Just really assholes. They don't have arguments. They just have ridicule and elitist, pompous, arrogant, to just douchebags. They take 15 minutes to say you're an asshole. They just don't say, hey, the guy seems pretty crazy, like he has some sort of psychiatric problem. There, we're done. It's kind of like Thunderfoot. It takes 45 minutes, and he just says the same shit over and over and over again, and just stokes it full of ads. So there's like, by the time you get through a half-hour video of his, there's got to be 45 ads. I mean, it sucks. It's just horrible. Anyway, I don't watch his videos regularly, so this isn't some blight I have to endure. But he's really not that interesting. He just plays the same clips over and over. Clips he took from somewhere else. I mean, it's just, it's just nothing original. I mean, really, he's just redoing 2020 episodes. It's just, oh, look, there's a doctor getting debunked for being a fraud. I'll debunk him some more, exactly the same way, using the clips from the TV show. Sorry, too stupid. So anyway, science just sucks. Frankly, the scientists suck. So that's the problem. And speaking of that, the Sabine Hassenfelder, at one time I saw a promise in this individual, but that was a mistake. Just an asshole. I mean, she makes a video called Flat Earth Science. Wrong, but not stupid. I mean, it's just so stupid to sit there and give any latitude to any kind of notion that it makes any kind of sense in the modern age for any human being to deny the existence of photographs and every single thing that maybe somebody else produces the evidence for you, a videotape of something. I mean, it's not, oh, I wasn't actually there to see the volcano, therefore the volcano didn't erupt. I mean, it's just such horseshit. This isn't what these people are doing. These people are overtly, okay, playing a psychology game, trying to suppress and distort human perspective. It's nothing but a silly religion, and it's being overtly proselytized by people who know it isn't true. There's no way anybody rational or reasonable can assert they are unconvinced by the evidence of the round Earth, the sphere or spherical Earth. It's just horseshit, just obnoxious horseshit. Now, you could say 4,000 years ago this was a reasonable debate, but there's nothing reasonable about it now. There's nothing. I mean, she's such a hypocrite. So she did a music video where she's, ragging on this idea of a unification theory because she doesn't see it as, interesting or even necessary. That, in the Feynman-esque kind of point of view. Here, a person who wrote a book called Lost in Math, and she's basically saying, lost in the I don't give a shit how it happens delusion. I mean, it's the same nonsense. Let's not try to figure out exactly how it works so we can actually then know better how to deal with it. I mean, it's a fact that we can't walk through brick walls, right? I mean, we could just make up some kind of crap about, well, it's made out of brick. We can just say, but it'd be really kind of interesting to know physically why, and to understand, oh, okay, so the electrons and protons are all magnetically held to each other. They all have mass, and when you add up all of their mass, they're kind of heavy. You need a lot of force to move them, okay? All of those little bits have to be moved for you to take that space, to displace them, to take them, push them out, to part the sea of brick. You have to move a ton of mass, and that's why you just can't walk through a brick wall, is because the mass doesn't want to do it, okay, because you don't have enough force, and so you can't do it. Your little bits don't have more force than the brick's little bits, and therefore the brick little bits won't get out of your way, and you're stuck having to move the whole brick to be able to get through the wall. Anyway, the real answer is a lot nicer than just saying, I don't care. Bent space. And again, so saying she's supposed to be some kind of dissident among the scientists, and it's just kind of a joke because she's a whore for all of their woo. I mean, there's two pieces of woo she doesn't like, I guess, some of the accelerator crap. I mean, I don't think she's a big fan of Higgs boson science. And maybe she's a little doubtful about LIGO's efficacy. But that's about it. The rest of the crap she buys into, every one of the silly little pieces of crap, the scientific community, every little troll they produce, every little silly doll, she'll buy one. So her dissidency should be respected, yet everybody else's dissidency is just too much trouble. Don't bother me. I'm not interested. And frankly, there's good reasons. Just overtly state what your reason is. Why don't you just say, well, if your unification theory is full of more gremlins than the current theory, then yes, no thank you. Okay, double gremlin theory, no thank you. So unless your unification theory is simpler and more complete, and I can see having standards, but she doesn't really have those. So anyway, just people are just so not likable. So anyway, everybody else is an idiot, a moron, kook, crazy, crackpot. It's just sad to say. It's just the world's just covered with it. So this is a minute physics video. there was a playlist of chronological order, and I said, what the hell? So this one's made in 2011 on gravity, the 3-minute version or whatever. I guess there's a commercial here again, but it says 125. But anyway, let's see. Yeah, that seems okay now.
We're all familiar.
It's 1 minute and 25 seconds. Phew, that really is minute physics back then. He doesn't do minute ones anymore, but anyway. But you can do this quick version, and it'd just be nice if they threw in a couple of extra details, just pointing out how, and that's just like a light bulb, just to give people an understanding of the mechanism, that there could be a physical mechanism.
With gravity as the reason objects fall, but there's much, much more to gravity than that.
Well, there really isn't. It's the reason why objects move. An object moves, and there appears to be no reason. So like magnetism or like some of these other things, there's an effect, and you're saying, what the hell caused that? Nobody banged into it. Why did it move? Why did it go down? So it goes to the edge of a cliff and then it falls down. It's moving. There's a good reason to ask the question, and the answer is going to, you answer that question, why the rock falls down the cliff, and you've basically answered all the questions you need to ask about gravity.
Gravity is a long-range attractive force between...
Well, all forces are long-range. All events that happen between objects. Electrons are communicating. Yes, that's true with electrons on the other side of the universe. It's just the communication takes a very long time because the distances are very great. But yes, everything is being communicated. I'm communicating right now with Alpha Centauri. We're communicating with each other. I'm reflecting energy, and some of it ends up maybe getting there now and then, a little piece of it. And likewise, it's sending energy, and a little piece of its energy hits me. And so we all know where each other is because we're all reflecting energy. Okay? And so we can tell what's happening basically on what's being reflected at us. And the trick is, if something decides to move away from us fast enough, we won't see it anymore. We won't be communicating anymore. It'll be invisible.
All objects with mass. It's what keeps us from...
Right, so all objects with mass, you could argue that photons have mass because they have momentum, so that's not really true. So when they say all objects, just say, look, the bits that are important, the material bits, electrons and protons have to do the moving, so why don't we just declare the parts that have to move, the parts that are moving? Gravity's a nuclear force. It doesn't move atoms, it moves electrons and protons. So that's where it happens. That's where the event takes place. Atoms can't be told what to do. You have to tell the parts what to do. So why doesn't physics deal with that simple truth? Does it really think an atom does something without its electrons and protons doing it first?
We're falling off the Earth. It's what keeps the Earth in orbit around the Sun, and it's what caused the Sun itself to form 4.5 billion years ago.
Yeah, whatever. So, yes, that's all nice little jibber-jabber, but, it also did a whole lot of other things, in terms of flattening the surfaces of the Earth, doing lots of things like that.
It's amazing to think that every massive object attracts every other in the universe.
Right, so why didn't you just draw an electron and a proton? Instead of still pretending this has something to do with big things, when gravity is a nuclear force. It really is just affecting electrons and protons, and that they're the things that are the substance of gravity. And that I can take one single atom and place it in space, just move it to the location of the Earth and give it the right velocity, the same velocity as the Earth, and it'll do exactly the same thing as the Earth, and it'll move exactly the same and stay in the same orbit and be gravitationally affected proportional to its size, and that's it. Not complicated. So it's a nuclear force.
That means that your dog, the Earth, and a black hole in the Andromeda Galaxy...
So he had to throw that crap in there, the magical black hole. So just as real as people and dogs and Earths are black holes, which are some stupid, idiotic notion that there's a bunch of electrons and they all get into one single place. Bullshit.
0.5 million light years away, are all gravitationally attracted to you, and you to them.
Yeah, well, again, it's not the black hole is causing the gravity. It's the little bits inside the black hole again. The Earth doesn't create the gravity. The Earth doesn't have a personality or something, and where gravity flows. No, the gravity is caused by all of the nuclear little bits, and the nuclear little bits move, and as they move, they change the field outside. So I gave you a simple, in previous videos, I've given you a simple explanation that there is just an energy differential that just happens to take place inside of any object that contains an electron. Because if an electron or proton moves from one place to another place, the idea is that it has to absorb energy to do that. It takes some force, okay, that has to be occupied moving, okay. So it gets occupied moving the object at something less than the momentum it had. So it had the momentum of c going in. It has the momentum less than c. It's the other way around, Gary. Going while it's pushing the matter. And then when the force is released, it goes back to being c. Yeah, it could be in another dimension, another direction. But it goes back into the force equilibrium. But the point is that it was actually diminished as a force for a little period of time while it had to move matter. And so that would be your differential. There's always force coming into everything in the universe is being hit by light energy, little bits of momentum constantly being hit, constantly reflecting. And the truth is that a material object, okay, like an electron, while it's moving, it's reflecting differently to the universe through the moving process. So the moving process is, in a sense, consuming a little bit of energy. So in the end, it will give back less than came in. And this is less. A less arrow. I don't know exactly how to draw a less arrow, just a tiny bit less. Okay. Oh, shit. I knew I say, hey, Gary, you got to remember to move the thing over. Yeah, so they can see it. So, yes, a certain amount of energy goes in, but for every movement, okay, there'll be less energy reflected to the universe. So you can sort of understand, while this moves from here to here, okay, it's not going to reflect energy that hits it this way. And so that energy, for a period of time, won't be going back out into the universe. It'll be delayed. And delaying energy is the same thing as kind of destroying it. You've taken a little bit of the heat out of the entire universal system. And by taking a little bit of that heat out, you change the equilibrium balance and create gravity. And so every object every time an electron moves, it steals a little bit of momentum in that direction. And so you can see if electrons are moving in every single direction, that they would be creating gravity in every single direction. So if you have enough electrons and protons, and they're moving about, jiggling, every time they move, they consume a little tiny bit of energy, and you can figure out that there's going to be less energy coming out than energy that went in, i.e. gravity. Now that's in my opinion, that's the easy, simple, complete answer, and it explains the phenomenon completely. You get it. The more electrons I have, the more energy I consume, the more heat I take out of the universe, because the electron moves a little bit slower than the speed of light. By moving a little bit slower, it takes a little bit of the energy out of the system. The speed of you can understand, the speed of the photons is the heat, right? If I change the speed of light, let's say I had a box and I just filled it with BBs, and the BBs were going 50 miles an hour. It would have a certain kind of heat. A certain number of BBs would be hit in the box. You could kind of get that's its heat. Now, if I reduced it to 20 miles an hour, you get it that's half as much heat. That's half as much pressure. Half as many BBs will be hitting the walls. I've reduced the energy of the system by reducing the speed. By reducing the speed of the force, by having it push, matter, electrons and protons, you consume the energy. Not complicated, really. All right.
the 17th century, Isaac Newton discovered that the strength of the gravitational force decreases by the square of the distance between two objects.
Right, and this is just so fundamental. So instead of explaining what the implication of that, what that means, okay, I mean, that, it's so critical, so fundamental, that's exactly what you would have if you understood point sources and understood radiation and the idea of something just radiating, something throwing something from one place in all directions. So if you have a point and it shoots something, every second it shoots something, it can be in any one of these directions, and it would be spherical, so it could go this way, in and out, this way, that way, up, down, left, right, in and out. And it's just like a spike, like a cactus, thorns, just sticking out in all directions. That this is the inverse square law, that moving in those two dimensions, that is moving away from each other this way and this way. Unfortunately, it's a little difficult to draw that. It ends up being a square. You're not moving just away from each other in this direction. You're moving away from each other in this direction, and that's why it's a square. Frankly, is it because it's that simple. The geometry of the math is that simple. It's just the difference between a line and a square, and the area is 4 times as much. So you did twice as much distance, but you got 4 times as much change. So the more it spreads, you can just understand that the closer you are to an object that's spreading, the more likely it is you're going to get hit. If you're this size, and if I'm this size here, and if I'm this size here, I'm obviously not going to get hit by as much paint or whatever I'm throwing. Cactus needles, it doesn't matter what I'm throwing them. And so, it's so kind of obvious that gravity's just the opposite of throwing. It's just saying, I'm not throwing. All right, everything else is throwing. I'm stopped throwing stuff. I'm not throwing as much. So you're simply in a pressure gradient, and the rest of the universe is still doing this way. And the gravitational object is just sending a little bit less coming out this way. And obviously the less, means you're going to be pushed into the earth. So it's so easy to describe why there's an inverse square law, that it's a mechanical function, that obviously if you thought of the earth having an insane, I can't even tell you how many zeros it is of the number of electrons, and that those electrons are moving in all kinds of directions all the time, and every time they move they're consuming a little bit of heat, a little bit of energy from the universe. We think of their movement as heat, but it's exactly the opposite. Their movement is absorbing heat, and it absorbs it in all these directions all the time. And so anything, any place is going to fall into the earth because the electrons are absorbing force that should be hitting them but won't be hitting them because it was slowed down. Its momentum was decreased for a period of time, and it changed the future.
So if you're twice as far away, gravity is only 1/4 as strong. He also discovered that the
Right, so that's just the opposite of saying it's twice as much or twice as little, depending on which way you're going.
strength of gravity is proportional to the mass of the objects in question.
Right, well, the strength of gravity, see, that's, making a tricky argument here. No, the strength is proportional to the mass because the mass has to make the gravity. The mass moving makes the gravity. So yes, the more electrons you have, the more potential there is that you're absorbing force and absorbing it in every direction. Now, if you only had one electron, the gravity would be in one direction only, the direction of the movement. That would be the only place you would notice any gravity. One electron can't produce gravity in every direction. So you'd need a certain amount of mass before you're going to have gravity that's going to obey the inverse square law. That's why the law changes when you're talking about charges, because charges are personal. They're not gravitational. They're doing something a little bit. Well, charge is probably a bad example because it does become spherical. The charge just is the reflectivity. It just has to do with how the electron reflects energy. So I shouldn't use that as an example. But you can just sort of understand that this is really about a collective thing. You have to have more than one electron for the gravity to be a point source, for it to be going in all directions, and for you to end up with consistent gravity from an object. And obviously it goes spherical for the very same reason, because of the fact that it does become, every little piece of chalk ends up being a little radiant point source, because it has a whole bunch of electrons in it. And all of that will condense into one proportional sphere that'll get very, very flat as the gravity gets stronger and stronger. Very flat in the sense the curve will become, there won't be much irregularity in the surface, because the gravity will destroy it all.
The more massive an object, the stronger the gravitational force.
So again, the stronger the gravitational force really just means the more you've absorbed energy and created a differential between the outside universe and the proximity of the object. The object is producing less than the universe is producing, and therefore you're going to be pushed into the object, because it's essentially created a kind of shadow, a kind of deficit, a void in energy.
That's why we can all feel the Earth pulling on us, but don't really notice the pull of the moon.
Yeah, and we don't notice the pull of each other, because there's not enough little bits in a tight enough space to absorb enough energy for us to feel the difference, to sense the difference. But the difference exists. There is actually gravity between us. It's just that it's such a tiny bit of differential in the light. So it's sort of like having a very bright, like a candle, on a sunny day or something. You could see the flame, but you can't really, it doesn't shine. It's not obvious. It becomes blurred by the noise, and so our gravity with each other is blurred by all the other forces that are affecting us.
It's smaller and farther away. The moon's gravity is strong enough to cause the tides, though. And when I said earlier that
I don't even know if that, why throw that in? It doesn't say anything. You're still not explaining gravity at all. You're not explaining what causes the effect. So it's just almost a lie to say this has something to do with gravity, because what is gravity? Well, telling us the moons make the tides doesn't really explaining what gravity is. So it's just, clickbait, because he doesn't give you any insight at all into what gravity is, and he could have made it clear that the inverse square law is a huge giveaway. The fact that gravity moves the speed of light, the speed of force, that is all the other forces, is another huge giveaway. Gravity's not instantaneous. It has to be communicated. If my body moves away from Alpha Centauri, okay, the fact is Alpha Centauri gets less energy from me. I reflect less light to it, and will in fact cause a kind of gravitational effect. It doesn't get hit with the energy because I moved away from it.
Gravity is an attraction between objects with mass. I lied. I meant objects with energy.
So this is more horseshit. It's not about objects with energy. The universe is what has the energy. The crap that your cell phone radiation that's flying through me right now, and all kinds of other stuff flying through me, that's the energy in the universe. The matter is dead. The matter just goes where the force tells it, just like the silly argument that the bent space tells the matter what to do. There's a certain truth to it, if they had the right answer, if bent space was gravity. But no, it's a real force, and the real force tells the matter what to do. So matter's dead. Matter's just balloons blowing in the wind. And when the balloon blows, it uses up some of the wind. Just like a sailboat, if your sailboat cuts in front of another sailboat, it blocks the wind, and the other sailboat slows down because there's no more wind. It uses it up. So when balloons are flying around, they're using up energy that the wind had. Some of its energy is lost to the fact that it has to move the balloon.
Because in addition to massive objects, gravity also attracts light and other massless but
So there he just said it. It attracts, which is not, it's not a very good statement. It attracts by the magic attraction. the magic pull force. Obviously, it's not a pull force, it's a push force, and all gravity does is create less push coming from one direction. I'm facing the Earth is pushing on me less than the rest of the universe is still shining. Okay, it doesn't have a bunch of earthly electrons between me and the rest of the universe to suck up all the energy, and therefore I get hit with more energy from out there than I get hit from below down there, and I move into the lower pressure. That's hardly attraction in any rational sense. And this whole idea that now somehow they've established that this force of light, like this, it's clearly energy moving the speed of light. It's moving the same speed as gravity. Clearly, it's probably the same stuff as gravity. And here we have the only incidence of the fact that this force actually acts on another force. All the other forces can't do that. You can't bend light with magnetism. You can't, all of the can'ts. You can't do anything with forces except move matter. Except this one exception where light is moved. And it's not just moved, it's moved twice as much as matter, which is even more ludicrous. So first, the moving part is already a cigar UFO photo, and now they're putting a smiley face on the fucking UFO. I mean, to make it go twice as much? Twice as much? How does that make any sense? Why would the fastest thing in the universe, a force, be bent twice as much by another force? Very suspect that that's a fact, but he just states it like, well, we have so much evidence, there's no point in considering anything else. And they're saying we have so much evidence that Mother Teresa is a saint or something, that angels exist. Their claim isn't any. The evidence sucks for this statement, and yet they just keep making it as if it's the solidest truth you ever knew. It says, as much as water is wet, gravity bends light. And it's nothing like that kind of hard fact.
Energetic particles.
Proven fact.
So that a photon of light can be bent slightly passing the sun, or trapped completely.
Well, again, it's not bent slightly. It's bent twice as much as an electron would be. Twice as much as a brick would be. Twice as much as an earth would be. Twice as much as a moon would be. Twice as much as any other object in the universe. Any other thing we can identify. And clearly more than twice as much as a magnetism, because it won't be bent.
By a black hole.
So black hole again brought up as if everybody has to believe in those. You just can't doubt that we can stack matter inside of matter, that I can take an electron and take another electron, just put them inside of each other, and then I can put those inside of another electron. I can have Pac-Mans that eat Pac-Mans and eat Pac-Mans and eat Pac-Mans. They never poo, they just keep eating Pac-Mans. And that all makes sense to somebody. I don't know who it could make sense to. I don't know whether this guy ever even thought about it. They just say this crap like it's okay, that's okay with me. Sure, go ahead, put the chalk inside of the chalk. Take this chalk and put it inside of this chalk, and then put that chalk inside of that chalk, and just keep for an infinite amount of chalk. Just pile it all into one little piece of chalk. The magical condense the chalk. Why would anyone say, yes, that's the default? Prove otherwise. No, I shouldn't have to prove otherwise. You should have to prove there's some reason to believe that crap.
Now do you understand the gravity of the situation?
Oh, so a little joke at the end, like, yeah, I've enlightened you, haven't I? I've given you so much information. I've really explained to you what this why the things move towards each other. Material objects end up moving towards each other if nothing else is, if this one doesn't have a motorboat, that's pulling it somewhere. If I take two little equal things in the equal universe, they'll end up moving towards each other. Well, why is that? Well, because they're both heat absorbers. They're both energy absorbers, and the energy won't be there between them anymore because they're both going to be seeing the fact that, oh, you're radiating less energy than the rest of the universe because you're busy moving matter. So simple. I mean, the answer is so simple. It's like nobody gave it any thought at all. The answer is just so simple. all you're looking for is why does a thing somehow create a absence of pressure? How does light get dimmer? And that's all. You're just saying everything's a competing light bulb, right? Everything's just sitting there trying to be a competing light bulb. You're just saying, why is that light bulb dimmer? It's dimmer because the pieces inside of it have used up some of the energy, and therefore it doesn't have as much brightness. Wow. We have to really work hard to find the right answer. No, the right answer is so simple, and they just talk this fucking nonsense. So the next one in chronological order was dark matter, and you're just saying, well, that's clearly just God of the Gaps mush. What a waste of time. So this next one's supposed to be wave particle duality, so let's watch that, because that should be quite silly also. Oh, they do all this like as if they really have authoritative truth, like they have a really great evidence. Again, the Eddington experiment never repeated. The resolution in space is 400 times better from a satellite, so they could do the experiment 400 times more precisely from a satellite in space, and there's absolutely no evidence that it was ever even attempted, and yet it would cost about $1.25. I mean, that's how much it costs. We see particle-like
behavior every day. Drop a ball.
That's how much it would cost to like move one of their, just turn their satellite to look at a certain piece of space. Yeah, $1.25. Really cheap.
On the ground, and it follows a single trajectory. Leave your giraffe parked on the street, and when you come back, it's still there. Just one giraffe.
So you wonder who these videos are for. I mean, in some sense, they're too sophisticated for, Barney the Dinosaur audience. And so, and the people who have read The New Yorker maybe once or twice in their life, or, a newspaper, do they really need the giraffe joke?
And we see wave behavior, too. Toot your horn, and waves spread out through the air, carrying...
So again, and waves spread out. And so what's a wave in atmosphere? It's a differential in air pressure. So you're basically just saying, I'm compressing atoms. Atoms are smashing into each other. And there's going to be a higher density of them in one place. And then another next to it will be a lower density. And then it'll be a higher density. And then a lower density. And each one is a real atom. And each atom was compressed by real circumstances. I mean, real houses next door. Like the houses actually did move into each other. And a house had to do the initial pushing. So the force hits a house, the wind blows, it hits a house, the house pushes closer to the neighbor's house, and that neighbor says, I don't like being that close, and he moves over into the other neighbor's yard and pushes on his house, and then it pushes on his house. And you can sort of understand it's personal. It's not something called a wave. It's a bunch of individual pressure points where the neighborhoods, this back street there, their backyard is moving into my backyard. This guy over here is moving this way. I'm getting hit by forces in different directions, but the tendency is to move all in one direction. And we're all tied to each other because we all have a certain size lot, and we're going to try to maintain our lot. So each atom is trying to maintain its property border, and we're just transferring, like musical chairs or something. We're just trying to transfer who gets the smaller yard. We're all competing with each other to force the other guy to have the smaller yard. That's what the atoms are doing in the atmosphere. It's not a wave, okay? It's an individual bunch of atoms, okay, that are being encroached on. Electrons are being brought too close to other electrons, and they're resisting. It's pressurizing the atoms, and the atoms are opposing the force by saying, well, you get closer to me, I'm going to shine more light at you, right? The closer I get to the light bulb, the more it pushes me away. Well, the atoms are doing exactly the same thing, and they're saying you can't get that close.
Sound to the ears of anyone around. Or drive a boat through water, and waves travel outwards along the surface.
So again, what does this have? It doesn't have anything to do with understanding what a wave is. So let's understand the wave can do two things. It's not no energy. It either creates a low pressure or a high pressure. That is, it either reduces the pressure or it increases the pressure. And that's the nature of what it's functioning as. So it has a push-pull kind of ability. It can, if there's more pressure, you move forward. If there's less pressure, you move backwards. Okay, so sound can create less pressure and make a vibration, make property sizes reflect that and try to renormalize. So again, you're making the lots bigger, and then people say, I don't want to be taxed more, so they try to make their yard smaller again so they don't get taxed more, however you want to understand it. But waves in mediums with atoms that are connected to each other, that are forced to be connected by property lines, they can do the expansion-contraction thing where there's no evidence that photons are doing that, in the sense that photons are either all or absolutely nothing. Photons basically are saying energy, no energy. That's the quantum part, the quanta. Okay, there either is a piece of a photon or there's nothing. There's no negative pressure in any real sense. I mean, obviously, an absence of pressure to an electron means move into the absence of pressure. So in some sense, it's the same. But it's not because the electrons are attached to each other. Well, that's kind of the wrong way to say it, too. Yeah, well, anyway, let's just continue. I mean, there's just no argument here about the fact that radiant force that leaves in rays, that pushes just in, like with fingers pushing, can look just like a wave, okay? A wave of soldiers, a wave of bullets. There's lots of things we describe as waves where it's not in a connected medium at all. And photons are not traveling through a medium. They're not doing anything in any kind of fieldy way. They are the field. The soldiers are the force. The atoms are moving.
But when it comes to the physics of the very small, what we see is a wave-particle duality. Sometimes very small things, we're talking electrons and protons here, behave like particles. And sometimes they behave like waves.
All right, so they never do that. So, it's just kind of silly to say they behave like a wave. Like the soldiers sometimes behave like a wave. No, the soldier always behaves like a soldier. Okay, now you can send the soldiers and imitate a wave. Send all the soldiers at once in all the directions, look like a wave of soldiers. Well, the individual soldiers don't know anything about that, okay? They're just got their marching instructions and they're just doing what they're told to do. There's no wave that isn't anything but just emergent and incidental.
Flip-floppers. For example, if you release an electron, it'll travel outward.
So the point to understand is there's no duality. Particles can look like waves. Waves can't look like a particle. So it's just understand, there's no duality. If you're seeing something that looks wavy, you can understand, it could be made out of particles. It could be made out of soldiers. Okay, there's no elemental wave. There's just soldiers that move in a pattern that we call a wave.
As a wave through the room, but when it hits the wall, it'll only hit in one place. You started with one electron, after all.
Right. Well, the very idea that the photon is one thing, and the light over here and the light hitting this hand are the same light. Somehow it's a wave that went across this whole thing, and it's hitting this hand and it's hitting this hand, was a stupid notion in the beginning. Just like the wave of soldiers. Like Jim is over here and John is over here. This is platoon 17 and this is platoon 6 or something. They're not the same soldiers. They're not the same platoons. They're not the same anything. All right, they're coming out as rays. Okay, it looks like a wave, but it's rays of force. That's why you got this so wrong. They got all of this elemental stuff wrong. It's just the truth, okay? Everything they've done since 1900 is garbage. These are all really bad guesses at the truth, not good guesses.
So what if sound had a wave-particle duality? When you shouted, the sound waves would spread outwards in all directions, but only one person can.
So again, the wave doesn't spread. The force of atoms hitting atoms spreads. So it's really Jim atom hits Bob atom hits Jane atom hits, it really is personal for the atoms. There's no wave that's pushing the atoms. It's some other atom pushing it. So one atom pushes it a little this way, and there's another atom pushing on it this way, so it goes this way, and then it gets pushed this way, and it goes that way. But it's all just a confined amount of interactions that are happening, and they're all happening for reasons that you can trace to a poke. Okay, something got pushed, and it pushed into the other things.
Hear what you said. Or when you drove your boat through the water, the waves would travel like normal, but only hit the shore in one place. Now that would make for some pretty boring surfing.
Well, again, it's only hit in one place. You mean all of the energy that went to all these other places somehow went to this one place. So he didn't even draw that to understand what they're saying. The whole energy of the entire photon that you say spread over all this area. Well, no, it never spread. It never did any of that stuff. The water wave never spread. Those are a bunch of individual paths of pressure. Individual atoms being pressurized by other individual atoms. There's no wave function. There's just the function of a bunch of pieces getting hit and the individual pieces moving. It's particles, okay? Electrons and protons are making those waves. There's nothing else making them. It's made of particles, just like light is made of particles, pieces. That was it. Amazing. Amazingly not very complete. I guess that's why I said part one.
Space.
So we'll see.
Geico is giving
Part
new and
two
current
is...
customers a 15% credit on their motorcycle policies with a Geico gift back. And because we're committed for the long haul, the credit lasts your whole policy term.
So he committed to a annoying ad, whatever, a 10-second ad or whatever, 15-second ad. I will force you.
Back, helping riders focus on the road ahead.
They gotta make all
In the
this
last video,
money
I
for
introduced
this
the idea
crap.
that really small things.
Oh yes, you're so special, and you're doing the world such a favor with this trite, trivial physics. Thank you so fucking much.
Things act sometimes like waves and sometimes like particles.
Yeah, acting like and being like seems like, that's horse shit, okay? Idiots know better.
So how can we actually picture this wave
Cold things can seem hot. We know they're not.
particle duality of, say, an electron?
It burned my finger, the cold thing,
Well, imagine our electron is a speck of dust in a raindrop. We know pretty well where the speck is at first. But when the drop hits the ground, it'll spread out.
So now they're doing something, and like, boom, boom, he's got to put this stupid fucking music on the damn thing to just fuck it up. I can't take it off, so we're stuck with it.
Out like a wave, and the speck of dust will be somewhere in that wave.
So more bullshit, right? There's no doubts. The photon not know where it's going, and the proof of it is that they know this thing travels across the whole fucking universe. Okay, the little bit of light goes billions and billions and billions and billions and billions of light years and hits a spot. Okay, we know why. We know the inverse square law. We know there's a bunch of these little bits of light going to very distant places, and there could be hundreds of millions, okay, of light years of distance between the little bit that hits here and the little bit that hits here, and they both left at the same frickin' time. On a very long journey. They're not connected to each other. They're not entangled. They're not doing any of that crap. It's a little piece of momentum. Ugh, this is so stupid.
So the speck, our electron, is guided by the wave. But there's
just too stupid. Guided by the wave. Doesn't make any sense. It moves in a straight line. It doesn't need to be guided anywhere. There is no. It's gonna go to one place the minute you shot the bullet. Okay, its trajectory was set. This whole wooey bullshit that there was some doubt about where it's going is just that completely unnecessary nonsense. You don't need to believe any of this crap to understand all the physical experiments.
still only one speck, and if you actually look for it, you'll only find it in one place. The wave...
yeah, duh. So yes, so again, that should be evidence to you that all of this horseshit you're talking is just that horseshit. It's just nonsense. And Feynman called this nonsense, okay? Feynman explicitly said they're not waves. Photons are particles. He said it overtly. He's one of the fathers of your quantum mechanics. And you're just saying, fuck you, Feynman, I don't want to say that. I want to believe in waves.
Will also tell you how likely you are to find the speck at any one point. If the drop splits in two, you're more likely to find the speck wherever there's more water. And
the drop splits in two. The photon splits in two. That doesn't mean anything.
That's pretty much how the wave-particle duality of quantum mechanics works. Each particle is guided by a wave, called a wave function or pi.
Oh, so it's just such polished shit, right? And, so in their universe, it's a very quiet place in their universe, right? Because, see, gravity can't be a force. All of this energy that's flying around me now, all has to be magical stuff in some place. It has to be inert. It can't be real energy. So your cell phone, your mirror, everything is not creating real energy or real stuff, because they have to make it all go away, okay, by this magic of guiding things and interaction. So what he's going to try to tell you is that this thing is traveling through space, and somehow because nothing is hitting it, nothing's interacting with it. So the electron is just here, and nothing's interacting with it, and it moves to here. And nothing interacted with it to make it move. Nothing reflected off of it, so it did this whole thing. It moved from here to here, and nothing hit it. Nothing reflected off of it. My whole point about energy and pressure, none of that exists, and somehow the electron just does. So this whole period of time, it could be a magical electron. It could be here, 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 because nothing hit it through this whole process. And I would argue to you, you gotta know better. The universe is full of energy. Little bits of momentum are flying around all the time. There's no place this electron can go. He's getting hit all the time. All of this little stuff exists as little bits. There's no way he goes from here to here without one of these little bits hitting him. And as soon as one of them hits, he has to stay here. He can't be here anymore, and he can't be here anymore, and he can't be all of this entangled crap and this superimposed crap. He's constantly being measured. The electron is under constant measurement. It's constantly being bombarded by little asteroids, or however you want to describe it. We always know where it is because it's always being measured. Yeah, we can't see all the measurements, right? So we're not aware of all the measurements, but the measurements are taking place all the time. This whole thing is such whoa.
Wave that determines the chances it'll be in a certain place or state. Easy.
The weird penis drawing. So again, just more horseshit. We know that's not exactly the interference pattern created, right? So that's just more crap. We know why more light goes through the slit in the middle is because there's nothing in its way. That only the light that goes near the surfaces is actually the light being diverted to these fringes. So this pattern is sort of a lie, because this is just error light. The ones that are the fringe light, the light actually being manipulated or moved, is a small percentage of the light in the single slit experiment.
Right? The hard part is figuring out the movement of the waves.
Oh, so that's part 2. Is there a part 3? Because frankly, that sucked. What is this? A commercial? I don't know what the fuck this crap is. So that's it, part 2. So that took care of wave-particle duality. That nothing. Pile of shit video. Probably got 1 million views for that piece of crap. Yeah, almost 2 million views for that piece of crap. Oh, God. Oh. It's just so bad. Again, this is the most unevidenced theory in hundreds of years, or I don't even know how to describe. I mean, it's such weakly evidenced nonsense, and to be held up by everybody as if it's proven, and only a reasonable person can't draw any other conclusion, and there's no other way. You can't think any other way. You can't believe any other way. You have to believe in this. You have to, because there's so much evidence, and there's just nothing. There's tiny little, oh, it seems like. And if you pick at it at all, again, you pick at the slit experiment, you figure out that sound doesn't do that. A single slit in sound, not the same. Single slit in water, not the same. So, you know, how can you argue it's just like a wave when it's not anything like it in those experiments? That experiment doesn't show it. So you'll go to the one that does, you know, and then you'll draw a picture that isn't accurate, that, you know, anybody who does a little bit of analysis of the double slit knows can't happen. Two waves won't work. There's two patterns. You got to have four sources to create the two patterns. So, you know, your wave theory is again in big trouble. And yet they just keep asserting it, asserting it, asserting it. Like the propaganda. You just keep saying it, saying it, saying it. We've proven it, we've proven it, we've proven it, we've proven it. All this stuff is proven. Dark matter's proven, this is proven, that's proven. And they throw them all in one big pile. Like every idea is equally proven, which is also ludicrous. You know, it's just so bad. You know, so poorly evidenced. And all this arrogance and all this you must believe. You know, we the elitist, you know, mathematicians say so. And that's all this is. Again, you can't get a physics degree without getting a math degree. There's no concept degree. There's no understanding mechanics. They haven't separated these subjects. Mechanical understanding, you know, which has some value. Understanding mass proportions, you know, quantities. Even understanding probabilities has value, but this woo math, no. All right, so this is just it's just tragically sad. I mean, it's pitiful. Benjamin Franklin mislabeled plus and minus. You could just go from all the mistakes made in physics, and it just seems every single time they have a choice to make, they somehow find some stupid reason to choose badly. You know, wave, particle, all these, you know, bent space versus real force. I mean, speed of force versus speed of light. I mean, you know, every time they had a choice to, like Maxwell, to figure out, well, did I just discover the speed of light, or did I discover the speed of force? You know, and they always choose badly. Alright, so that's it for today. Yeah, just such a depressing way to start my day. I probably should make the videos at night, but then I probably won't sleep well. Anyway, I can't make you reasonable, but I mean, you should be able to concede the evidence isn't what it needs to be for this kind of arrogance. This closed door, we know it's true horseshit. They just don't have the evidence to defend that crap. And again, your choice is silly, gremlin-y, wooey, bent spacey, Heisenberg uncertainties, it's baby religion. It's a, you know, it's the abiogenesis of religion, you know. Make believe, magical. It looks on its face, it seems like pretty bad science. It seems like really close to religion. Bent space sounds like flying gremlins.